Now on to Unit 5, Lesson 4, Problem 4.2. This problem has multiple parts, and we're going to have to fill out a little table here. So let's get started. Question number 1. Here we go. We have a rectangle with length 5 units and width 2 units. We want to know what is the area of this rectangle. So a couple different ways we could do that. We know that we have a length of 5 units and a width of 2 units, so we could count up all of the 1 by 1 squares inside there and get 10 square units, or we're quite a bit smarter than that. We can use the formula for the area of a rectangle, which is the length times the width, and our length is 5 and our width is 2, so we know that we have the area of 10 square units. 10 square units, the area of that rectangle. Moving on now, number 2 says, dilate the rectangle ABCD from point A by a scale factor of 2, and then calculate the area of the image. Okay, so if we dilate with respect to point A, and there it is, with a scale factor of 2, that means that all of these points move twice as far away from A as they already are. So since point D is 2 units away, that means D prime will be 4 units away. And since point B is 5 units away, point B prime will be 10 units away. And the same thing for C prime. Okay, so here's our new rectangle. We have this new rectangle. Now what we want to do is we want to calculate the area of this image. Well, I know since I dilated segment AD by a scale factor of 2, that means the length is twice as big, so it's now 4. And the length of segment AB prime is going to be twice as big as 5, or 10. Now we can find this area by doing the length times the width. Our new length is 10. Our new width is 4. So the area of this rectangle is 40 square units. Okay, moving down. What we're going to do is we want to dilate this rectangle now by a scale factor of 3. So that means it's 3 times as far away. D triple prime will now be 6 units away from A, and B triple prime will now be 15 units away. So there's B triple prime, 15 units away. So here's our new rectangle. Again, the area is going to be the length times the width. The length is now 15 units, and the width is 6 units, and 15 times 6 gives us 90 square units for the area of this rectangle. Okay, down here to number 4, what we want to do is we want to complete this table. So I have a new scale factor here, 0.5. I'm going to skip this, and I'm going to do a scale factor of 1 means that it's not going to change from the original. So the scale factor of 1, the area is going to be the length times the width, and that's going to be the 5 times 2, and that is 10 square units. I'm going to use U squared Actually, we'll just leave it. We won't write any units of measure right now, but it's 10 square units. Next, the scale factor of 2, we did the area was the length times the width. And remember, our length changed by a factor of 2, our width changed by a factor of 2, and this became 40 square units. And then we're going to skip 2.5. We'll go to 3, remembering that our area was the length times the width. Our new length was 15. Our new width was 6, and that was 90 square units. Now, let's do a scale factor of 4. So if we scroll back up here, remember what's going to happen to our original area or our original rectangle here. There's my original rectangle. If I'm going to dilate this rectangle with a scale factor of 4, that means that this length will be 5 times 4, or 20. So the area is still going to be the length times the width. My new length is 20 units. And my new width, it was 2, but it's going to be 4 times that, or 8 units long. 20 times 8, I get 160 square units. Now we can go back and we can look at 0.5. So if I'm going to do the area as a length times the width, if I dilate this bottom piece, this 5 unit length, by 1/2, that new length is 2.5, because that's half of 5. And this length that was 2 units by 1/2 is a length of now 1. 2.5 times 1 is 2.5 square units. Now if we do the 2.5 here, the area is the length times the width. If I take 5 and multiply it by 2.5, I get 12.5. And if I take 2, which was the original width, and multiply it by 2.5, I get 5 units. 12.5 times 2.5 gives me 62.5. Now, what I want to do is I want to figure out the factor by which the area changed. So let's remember what my original area was. My original area was this 10 square units. So what I want to do is I know that I'm multiplying 10 by some value and getting 2.5 out. Okay, so what do I have to multiply 10 by to get 2.5 out? Well, if I divide both sides by 10, I get an x value here of 0.25. Okay, and let's just make sure. So if I do 2.5 divided by 10, and it's 0.25. Now, normally when we're talking about scale factors, remember back when we did scale factors, we said we usually want those written as a fraction. So to write this decimal as a fraction, watch what I can do. I can use the math function, choice number 1, change my answer to a fraction, hit enter, and that scale factor now is 1/4. So next, my scale factor here is going to be a 1, right? Because this 10 did not change. What's my scale factor going to be here? Well, what do I have to multiply 10 by to get to 40? That's simple. That's a 4. Here, what do I have to multiply 10 by to get to 62.5? And that is 6.25. And 6.25, written as a fraction, is 25 fourths. What do I have to multiply 10 by to get to 90? Well, that's a 9. What do I have to multiply 10 by to get to 160? And that is 16. Now, what we want to do here, what I'd like you to do, is I would like you to notice the relationship between these scale factors and these factors by which the area changed, and see if you can draw a conclusion. So if I take 0.5 and I write it as a fraction, that is 1/2. If I take 2.5 and write it as a fraction, that is 5/2. I have no other fractions, but look at the relationship here between 1/2 and 1/4. Look at the relationship between 1 and 1, 2 and 4, 3 and 9, the 4 and the 16. I hope you recognize that this factor by which the area changes is just this scale factor squared. If I take 1/2 and I square it, 1/2 squared is the same as 1/2 times 1/2. Fractions I multiply straight across. 1 times 1 on the top is a 1. 2 times 2 on the bottom is a 4. Look what my scale factor for the area is. So this is really not coincidental, and we're going to explore this a little bit algebraically in the next video.